Good morning, SEOUL. Good to see you all made it out here after last night. I'm sure some of you had a lot of fun. My name is Jameson Lopp. I am the Chief Technology Officer at CASA, and at CASA our primary mission is to help individuals retain and gain their sovereignty. And that's a very broad statement, but specifically we're trying to do that by helping people manage their private keys better so that they can actually be their own bank. And we're helping people operate their own nodes on the Bitcoin and Lightning networks right now to enable them to be able to verify that no one is breaking the rules on these networks, and really empowering these individuals to be a part of consensus. And that's really what I'm going to be talking about today, is consensus and the governance aspects of these networks. What I'm going to try to impart upon you is my view of what I believe the true value behind blockchain systems is. There is a lot of hype out there these days. My understanding from talking to a number of you is that at least in Korea, a lot of the focus has been on the investing aspect. And I believe that what I'm going to talk about today is applicable both for investors and for developers, really for anyone who's trying to evaluate the different systems and build and extend the systems that are already out there. So, what is a blockchain? We, of course, must begin at the beginning. I'm a technologist, and when I see a lot of people talking about blockchain this, blockchain that, I think that we are using blockchains a little bit too broadly in the sense of the term. So I hear blockchain and I hear database. It is a new type of data structure. And what is that structure? It is a cryptographically linked list of data. What do you get from this cryptographically linked list of data, these blocks and transactions? Well, you get two things. You get a means of ordering things that happened in a history. You can say this happened before this, which happened before that. And you get a bit of tamper evidence, meaning that if you have the blockchain and someone tries to go back in history and change something, you can very easily audit what happened in the history and see that somebody tried to change the history. You may or may not know why or how, but you can at least tell that some tampering occurred. But what is a blockchain not? A blockchain in the specific technical sense of the term does not necessarily have any of these things. It's not necessarily a network or a consensus protocol. It certainly is not an arbiter of truth. You still have this garbage in, garbage out problem, just like any other database. It's not even really a trustworthy timestamping service. In order to have that type of guarantee, you need other pieces of functionality to basically constrain the timestamps that are being put into the data that's going into the blockchain. The immutability is something that we hear a lot about. That's a fairly charged word, which you can have a lot of debates about. But a blockchain is certainly not immutable in and of itself. You once again need to have some sort of other mechanism that makes it extremely expensive for anyone to go back and rewrite the history of the blockchain. Whether that's proof of work, proof of stake, or some other consensus protocol is not particularly relevant. You just need it to be expensive from some sort of resource standpoint. And of course, a blockchain is not necessarily an ecosystem of diverse participants, though I would argue that that is what tends to give these blockchain-based systems a lot of value and enables them to be more robust as more people are expending their resources to develop these systems. So my main point, just from the intro here, is that a blockchain is not magic. It is not a piece of technology that you can throw at a problem and automatically create a revolutionary solution. We have to be very careful about how we actually apply blockchain technology to specific problems, and hopefully from the rest of this talk you'll get a little better idea of how I look at and evaluate blockchains to try to understand whether or not they're really adding value to the system that's being built on them, or if they're just being used as a buzzword to try to build hype and get people interested. So the title of this talk is about inverting bureaucracy. And what is bureaucracy? Well, it's really like the system through which we enact policies and enforce policies. And this is a very broad definition again. We could be talking about public organizations, private organizations, really any type of human organization. If you look back over the history of basically written history of humanity, you can see the way that we have evolved our society, and it really makes a lot of sense. That in order to create a society and an economy that is more efficient and able to be more productive, we've created these hierarchical command and control systems. It makes a lot of sense that we have basically created these leadership power structures where power is at the top and it is really managing another layer of usually managers underneath it, who are then managing other people, who ultimately are managing the people who are really on the ground getting things done, doing the hard work. This is efficient because it allows the decisions to be made by a small number of parties. They don't have to spend a lot of time necessarily arguing with each other, and they don't have to argue with all of the people that are doing the work. They are just commanding, and the people are doing because the incentives within the organization make them want to follow orders so that they continue to be able to pay for their livelihood and continue to sustain themselves. Now, this makes sense and it's great for all of us because it means that you don't have to worry about growing your own food anymore. Instead, you can outsource this to a specialist. And we have outsourced probably the vast majority of things that we're using in our day-to-day lives to third-party specialists because those specialists know what they're doing and have become exceedingly efficient and productive at doing that. And so it makes sense for us not to have to worry about learning how to do all these various things that we need to do just to operate our day-to-day lives. The downside to this, which I don't think many people have really started thinking about much until recent history, is what are the trade-offs? Well, we are concentrating power in the hands of a few people, and that's creating systemic risk. It means that we are creating incentive structures that can be abused. And we see that in a number of different sectors, but especially in like the financial industry with the crises that have happened over the years. People can sometimes have perverse incentives where they end up doing things that are very helpful for those who are in power and at the top, but can in fact be harmful for the rest of society. So bureaucracy and governance are very similar things in the real world when we're looking at human organizations. Generally, bureaucracy and governance create this feedback loop where the organization is created and the policies are put into place, and usually those policies also include the governance policies of how do we change and update the bureaucracy and how does the organization evolve over time. When we're looking at a public permissionless crypto asset network, I would argue that these two things are actually even more tightly coupled and may in fact be indistinguishable. Because what you're doing when you are operating a node on one of these networks is that you are deciding what the rules are that you agree to, and you are validating that nobody is breaking the rules to which you agree. So you are actually participating in an automated fashion as part of the distributed governance of that network by deciding just for yourself what you agree with and what you disagree with. So why do we even have governance and bureaucracy? Well, the bureaucracy, of course, gives us that efficiency and specialization that makes it easy for society to continue to evolve. Governance, of course, is more focused on the aspect of how do we change things and how do we help these organizations evolve over time. And there's many different ways that you can go about doing that. From a very broad standpoint, though, the reason that we have governance is that organizations need to make decisions. And here on the bottom right, you see sort of a technical diagram. When an organization needs to make a decision, the people in that organization, they generally have a high time preference. They want that decision to be made as quickly and efficiently as possible. They don't want to spend months and years arguing with each other, trying to come to a perfect consensus. So we create a decision function. This decision function takes in inputs, which is usually votes of some kind from participants in the organization, and it spits out an output, which is the decision, which is that's what we are going to do as an organization. Now, there are many different ways, like I have everything from a sort of autocratic dictatorship here to democracies, to republics, to what I would argue the public permissionless crypto networks are, which is more on the anarchy side of things. The downside, though, to voting, while it does give you much more efficient, fast decisions, is that I don't think there's any perfectly fair form of voting. There's a million different flaws when it comes to voting, usually around who votes or who has different weights of power, or even who has different levels of information and best understands what the vote is about. But just for a few examples here, on the bottom left is a carbon vote that happened on the Ethereum network a few years ago when the DAO hack occurred, and people wanted to decide, how are we going to react to this, $100 million Ethereum hack? Well, if you actually look at the statistics, the first problem that happened with this vote is voter apathy. Only about 10% of the Ethereum monetary supply was even used to participate in this vote, which was fairly important because it resulted in a major change to Ethereum. And then if you dig down into the votes themselves, 25% of the votes were from a single entity. And that was just due to the distribution of the money at the time, and that entity decided that they were interested enough to make the vote. So those are just a few flaws. Whenever you're arguing about fairness, you're probably not going to make everybody happy, but I think that most people can agree that there are a lot of different flaws when it comes to voting. When it comes to anarchy, however, voting doesn't work. A lot of people try to apply voting to these systems of anarchy, but the best approximation that you can actually come to is actually signaling. Now, the difference between voting and signaling is that when you are voting, whatever the output of that decision function is, that's what happens. And if you disagree with it, if you're in the minority or you're just not on the winning side of that decision function, it doesn't matter. You have to comply. The system is built that way, and it's more efficient. On the other hand, with signaling, instead of forcing and in some ways coercing people who disagree to go in a certain direction, you're just putting up a flag. It could be a digital flag or a physical flag, or something that indicates to the rest of the ecosystem that I have decided I am going in this direction, I am making this choice, I am making this change. If you agree with me, if you want to follow along and we stay together as an organization, then you're free to make the same change, and we'll stay together on the same network and agree with each other as to the rules. But if you don't agree, no one can force you to come along. You can continue doing what you're doing, and we may or may not continue interacting with each other, depending upon whether or not there's a conflict between this change that we're making, whether or not it's compatible. So the result of talking about voting and governance and all these things is that a lot of people try to shoehorn the governance model of these permissionless systems into well-known and understood governance models that exist in other organizations. So we often see people who get frustrated because they think that changes are not happening fast enough, or the changes they want to see are not happening. And usually they will come up with some sort of scapegoat or some sort of mental model that says, hey, it seems to me like there's a lot of power in this group of people, and therefore they are the ones that must be controlling this network. So some examples in Bitcoin, we see some people say, oh, this developer organization is controlling everything that's happening because they're the ones that are writing the code, and therefore the rest of the network is actually having to follow along with what the developer organization is doing. Or you might see other people who say, well, no, actually it's the miners. The miners are creating the blocks that are going out onto the network, and therefore, whatever blocks that they're creating, those really decide, what rules they conform to. Because if the miners are creating blocks that nobody is agreeing with, then the network basically ceases to exist, because the blockchain does not continue to get blocks added to it. And you can go around and argue about where the balance of power is in these systems for years, as a number of people have done. But I think that is actually kind of a fruitless endeavor. I think it's more interesting and more helpful to talk about self-governance and how this different model of inverted bureaucracy actually comes about. And in case you can't read it, what we have right here is actually a very simple description of how the lowest level of network data propagation happens on these networks. So if you're operating on Bitcoin, Ethereum, Litecoin, really any of these public permissionless networks, then what happens when someone creates a new piece of data, whether it's a transaction, a block, whatever, is they go out onto the network and they connect to some peers and they say, hey, I have this transaction or this block. Do you want this? And then the peers that are connected to them, they take it, they look at it, they check all of their rules, and if everything looks good, they say, yes, I find this acceptable, this conforms to the rules to which I agree, I will take this data. They then turn around, they talk to all of the peers that they're connected to, and they say, hey, I have this data, do you want this? And those nodes do the same thing. They look at it and they decide whether or not the data is valid and whether or not they want to store it and give it to the rest of the network. And this is the fundamental act, I think, of how inverted bureaucracy or bottom-up governance happens on the network. Because if someone comes onto the network and they have some bad data, some fake transaction or fake block or something that breaks rules with which people disagree, then they can offer it to other people. But the nodes will inspect that data and they will say, doesn't look good to me, no thanks, I don't want it. And the interesting thing from this is that the nodes, they don't actually have to do anything. They just have to throw up their hands and reject it and say, no, I'm not going to take it. They may end up disconnecting from that other person if they think they're being malicious, but ultimately it is this new veto power. It is this power of apathy or power of rejection, where you have to actually convince the rest of the network that it should accept whatever you want to put onto it. And what is the result of this? Well, the result is that we have this mesh network. It's actually a mesh of many other meshes. And these nodes, they're all talking to each other. They're automating the bureaucracy of the network 24/7, 365, all day, year-round, while you sleep, doesn't matter. You basically, when you're running a node on this network, you have created an extension of yourself and the rules to which you agree, and you have this auditing mechanism that is running for you and checking all of the rules to which you agree. And this is propagating the information around the network, and it results in this beautiful thing that I believe is this visualization of this new organism. Really, Ralph Merkle, who is a prominent cryptographer, he actually described Bitcoin as a new form of life. And what we're looking at right here, this is actually slowed down to 500% slower than it really happens. This is a block on the Bitcoin network, which is being propagated around. And basically that process that I just described a couple slides ago is happening within 2 seconds. This is slowed down to 10 seconds so you can see it, but within 2 seconds, this data gets propagated globally around the entire world. And we can come to a consensus about updates to this distributed ledger. And I think that this is a fascinating, new form of human coordination and human organization that is a lot more robust and in some ways more fair and equitable than current hierarchical organization structures. So this was actually a tweet that a guy called Michael Goldstein put out a year or so ago, where he was trying to talk about the balance of power in these networks. He was basically making an argument that on these networks, everybody is watching everybody else. And if you try to break the rules, you basically get kicked out. This is a more graphic way of trying to show, kind of like a Mexican standoff. But another way to visualize it might be, we have kind of lines between us, maybe strings connecting us. And instead of pointing guns at each other, we're holding a scissor. And we're going to cut that line if we believe that you're breaking the rules, and essentially cut you adrift, and you end up on your own network, which is not going to be very valuable. So my argument about all of this is that I would pose to you that on these systems, we're actually creating a new form of governance where we're giving the power of the veto to the individual that is as strong, if not potentially in some ways stronger, than the power of democracy or the power of overwhelming minority via majority vote. And that in some ways, it seems that these systems are actually more robust and equitable because you have a say that is so strong that no one can overwhelm it. A miner, for example, could expend many joules of energy in hashing a block and creating a valid block together. But even if they've spent $100,000 worth of energy to create that block, they can send it to your node that could be running on a $50 Raspberry Pi, and that Raspberry Pi can inspect it and say, you know what, you broke the rules to which I agree. I don't care that you have expended all of this work, all of this money. I'm rejecting it. This power of voting gives a great amount of power to those who actually don't need to expend a lot of resources to do so. So when we're looking at these different blockchain-based platforms, there are a lot of different variables at play. And people throw around the word decentralization a lot. It's another one of those hyped up buzzwords. But usually when people talk about decentralization, they don't talk about which specific variables they're really meaning. I think it's very important that if you're trying to evaluate one of these systems, you actually have to look at all of the different variables. And if any of these particular participants or pieces of these ecosystems are too centralized, then it can really hurt the value of that system. So some examples. There are a number of tokens, some on Bitcoin, a lot of them I think on Ethereum, but a number of tokens that are built on these distributed decentralized networks, but when you actually look at the smart contract code that the tokens are executing, they'll have backdoors, or they will have abilities built into them that give an overwhelming amount of power to a single entity, usually in the form of censorship. So if you're using a token where the issuer of the token has the ability to blacklist or claw back or essentially freeze your money, then what is the value of running one of those tokens on top of a supposedly censorship-resistant blockchain? It seems like you have really thrown out a lot of the value of the network, and in fact, the token may mainly just be marketing itself as being on a distributed network. So another aspect that can come into play, which is a little trickier to understand, is that there are also many forces, of course, that tend to centralize naturally over time, especially like mining with hash power, or some pieces of infrastructure like exchanges and companies. And you have to be wary and be careful about what's happening in these systems. A good example of that is actually if you were following along a lot of the Bitcoin scaling drama last year and what happened with SegWit 2x. There was a consortium of companies. Actually, one of the companies that I was working for at the time was part of this consortium, which made it very fascinating. But this consortium of companies came together and said, you know what, there's a problem, and the changes aren't happening fast enough in Bitcoin, but we represent a large portion of users and industry, and we believe that we can kind of get these changes pushed through the ecosystem. This was very alarming to a lot of us that people even felt like they had the power to do that. Thankfully, through a series of very complicated events, the whole Segwit 2x thing ended up kind of going away in a cloud of smoke. But we also ended up having an interesting forking situation around that same time with Bitcoin Cash. And Bitcoin Cash has been a fascinating experiment to watch play out, because a lot of the people in the Bitcoin Cash community got frustrated with Bitcoin, and they actually, in many cases, followed the miner model of saying, you know what, we believe the miners have enough power in this system that we can kind of get them to get the ball rolling and then follow them to get changes and upgrades made to the system. And you know, that has been fascinating to see that play out, especially over the past year or so, when just a few weeks ago, actually, they ended up having this contentious fork where, once again, we saw some of the issues that come into play when there's just a small number of people who have amassed a large amount of power. So they ended up forking again, and now there's multiple different Bitcoin Cash chains, and it's been a real mess. But you know, this is kind of the result of, I think, anarchy. We get to see these governance systems play out in real time, and a lot of people are just experimenting with them. But to kind of get to the end of, you know, how I'm viewing the value of these systems, I believe that a lot of people are focusing on technical scalability of these systems, which makes sense because blockchains are notoriously inefficient and difficult to scale from a technical standpoint. But what I think a lot of people are overlooking is the social scalability of these systems. So Alfred Whitehead, he said, civilization develops by increasing the number of important operations that we can perform without thinking about them. And what was he really talking about? Well, he was talking about something that, if you're familiar with Dunbar's number, it's really talking about the human mind can only really keep track of 100 to 150 relationships with other people. So we're not talking about the technical resource requirements for running these systems, but rather, when we talk about social scalability, we're talking about the cognitive load that is required to operate in these systems. Really, if we're able to reduce the cost of participating in these systems, then we're able to get more people to use them and stay in them over the long term. And the real power behind these blockchains and permissionless systems is the ability to minimize the trust of the users and distribute the power so far and wide that you don't have to worry about other users in the system making changes to the rules and basically pulling the rug out from under you. Because if you're constantly having to worry about other people changing the system in which you're operating in, then you expend a lot of your cognitive resources worrying about that, worrying about what these people are going to do. So if we're thinking about the social scalability of a system, it needs to be a global type of language and rule set. Really, the more a system depends upon local laws, local customs, local languages, the less socially scalable it is. And I believe that these blockchain-based systems, if they are carefully constructed, can be used to reduce the vulnerability for their participants. And when we do this, we can preserve critical functions. And Bitcoin, for example, preserves the integrity of the creation of money and the movement of value. But I believe that what we're going to see happen with these blockchain-based platforms is we're going to see a lot of different platforms come out that basically improve the integrity of very important economic matchmaking functions. And that's a fancy way of saying, disintermediation, getting people to interact with each other economically in ways that are no longer reliant upon trusted third parties. So to sum it all up, these blockchain-based platforms enable us to build truly free markets. And for the first time, these free markets are actually socially scalable. And the way that we can achieve that social scalability is through inverting bureaucracy. So, this has been a lot of content, I think, to digest in a short period of time. I hope I've explained it in a way that is somewhat easy for you to digest, but I find this all to be a fascinating experiment, and I'm very looking forward to seeing where it goes. And if any of you have questions or want to talk more about this, I'm happy to catch up with you after the talk. Thank you.